So what we got behind us right here is the Form 4. This is our latest generation stereolithography printer, desktop stereolithography. Specifically, it's using a process called MSLA, or mask stereolithography. So what this really means we have going on here is we have a UV source down here in sort of the guts of the printer, and we're using an LCD screen to create a mask so that we can basically create a UV flash and get an entire printer layer done at one time.
Yeah.
Previous generations would have been more traditional SLA, which is basically where we would have had a single laser point tracing, point by point, layer by layer, and was just a relatively slow process compared to what we can do now.
So that's a whole screen flash.
Whole screen flash done at once.
Yeah.
So functionally what that means is we're getting printer speeds about 3 to 5 times faster than previous generation printers on the market.
Got it. And if you compare it to a more traditional FDM printer, what's that difference like?
Yeah, great question. So filament versus SLA, there's going to be a few key differences. My favorite side is the material differences.
Yeah.
With the filament style printers, we tend to see a lot of sort of failure modes with the layer lines. When we put those parts under tension, torsion, we see those fail quite a bit. Where over here on the SLA, with what we see here, these parts have real chemical binds between all the layers. So it is one homogeneous part. So it doesn't matter how we twist it, bend it, drop it. We get a lot more functional strength out of these parts, which we might not have with a traditional filament style printer.
Yeah, I know a couple friends who have some resin printers, and they use it specifically because of the additional detail that you can get.
Absolutely.
So what's the resolution that we can expect from this printer and compared to your previous generations?
Yep, great question. So with this printer specifically, it does depend on which material we're working with, as always. With our higher definition materials, we're typically looking at about 25 microns. For most people, honestly, that ends up being a little bit overkill. So we operate with most of our materials at 50 microns, but we understand there are specific applications where, hey, we really want this extra level of detail. We really can't see the layer lines at all. So that's why we do have those with further capabilities.
Got it. So I understand that if you have a laser, then maybe having higher resolution means a slower print. But if you have a whole screen flashing at once, is there a trade-off to getting the additional resolution?
Great question. So is there a trade-off for the speed, effectively?
Yeah.
So great question. So with this one, thankfully, there's actually a whole bunch of different pieces of technology that we're seeing across the industry as a whole now with the LCD tech. Specifically, people always like to look for higher resolution screens. So with this one, we are operating with 4K.
Okay.
There are other printers out there with higher resolutions, but we've sort of engineered our way around those to make sure we're still getting best-in-class resolution with the printers themselves. Specifically with this one, there's two other pieces of technology I like to call out. The first is something called columnization. Effectively, what that means is we actually have a lens array down here. Unfortunately, I don't have one to show you. But what it's doing is it's taking that UV source and going to actually make sure all those light rays are literally traveling parallel in the vertical direction to each other.
Okay.
And what that's doing is making sure there's no dark spots on the build platform, which we might see with a more hobbyist level printer.
I see. Yeah. And this printer seems a little bigger from the Form 3. So is the build volume the same?
Great question. So this is actually a little bit bigger than the Form 3. Great observation. It's about 30% larger than the previous generation. Most of that comes from a bigger build platform.
Got it.
Previously, we had about a 5-inch by 5-inch build platform, so we had a perfect square. This one, we've actually upped it to 5 inches by 8 inches, so we're getting a slightly bigger aspect ratio on the build platform, which means we can fit more parts on the build platform while also printing longer parts because we're able to tilt them at a longer angle than we would have been on the previous printer.
Got it. One thing that kind of scares me about using a resin printer is the post-processing. So with a traditional FDM, I just grab the part off the plate and it's ready. What's the post-processing like for one of these?
Great question. Yep. So with SLA, there's always going to be 3 primary steps. There's going to be the print stage, the wash stage, and then we actually have a cure in the background over here as well.
Yeah.
That's still pretty standard for the SLA market, but we have tried to do a few things to make it a little bit easier. First off, we are finally at a point with SLA where we can print directly on the build platform, which is something we would have struggled with previously.
Wow.
That is because we have here this flexible build platform. So you can probably see those tabs there on the top of the build platform. Once we're done printing, what we're going to actually do is literally squeeze those tabs together and your part pops right off, which is something that never used to be the case with SLA specifically. So we've seen a lot of the market shift to this just because it's a much more useful mechanism versus a traditional scraping motion to get those parts off.
And so do you need this piece of equipment to do the wash for the printer, or can you kind of DIY your own solution? What's the benefit that this offers?
Yep, so there is always the DIY option. This is mainly just kind of automate it and make it as simple as possible.
Okay.
Fundamentally, what we're looking at here is an isopropyl alcohol bath. You can take the build platform right out, drop it right here in the wash. There's normally brackets right here you would mount those to. But there's the DIY option if you don't want to put the money into this. You can basically do by hand with IPA, by hand, easy, no problem.
Yeah.
Sure thing.
Awesome. Yeah. Thank you very much.
Awesome.
It's great to learn about this.
Yeah, appreciate the time, guys.